In the two-phase locking protocol, rollbacks may cascade. So let's have a look at the schedule shown on this slide. Let's assume that the first transaction is aborted for whatever reason, maybe due to a conflict with another transaction. So the first transaction is aborted and the second transaction tries to commit. So what should happen here? The problem is that the second transaction has read a value that has been written by the first transaction. So if the first transaction is aborted, then this value written by the first transaction is not valid, is never committed to the database. So the second transaction has read an illegal value and needs to be aborted as well. So the commit of the second transaction will fail and will also result in an abort and a rollback of the second transaction. Let's have a look at the scenario shown on the slide. Here we have 4 transactions and the transaction T1 is aborted. So what should happen here? First of all, note that T2 and T3 have read the value that has been written by T1, the value of x. So first of all, T2 and T3 must not be allowed to commit until the fate of T1 is known. Until it's known whether T1 was successfully committed or aborted. Now that T1 is aborted, it also means that T2 and T3 must be aborted as well, because T2 and T3 have read a value that has never been committed to the database. So these 2 reads are dirty reads. Moreover, since T3 is aborted and T4 has read the value written by T3, it means that also T4 must be aborted. So this example illustrates that these rollbacks can be cascading. They can cascade for more than one level. A schedule is said to be recoverable if the following condition holds. If a transaction T2 reads a value written by transaction T1, then the commit of T2 must be delayed until after the commit of T1. If T1 is not yet committed, then this read of T2 is a dirty read. So we must not allow T2 to commit before we know what happens with T1. We first must know whether T1 commits or is aborted before we allow T2 to commit. Because if T1 is aborted, then also T2 needs to be aborted. So every schedule should be recoverable. We say that the schedule is cascadeless if the following holds, if we only read values that are produced by already committed transactions. So, more precisely, if a transaction T2 reads a value written by T1, then this read is delayed until after the commit of T1. So if we delay the reads until after the commit of the transaction that has produced the value, then there are no dirty reads. And then the rollbacks do not cascade. So it means also that all cascadeless schedules are always recoverable. Let's have a look at the schedule shown on the slide and let's determine whether the schedule is cascadeless or recoverable. So here we have a read of a value A, and this value A has been produced by the transaction T1. This read is not delayed until after the commit of T1, so the schedule is not cascadeless. If T1 is aborted, then also T2 needs to be rolled back. Is the schedule recoverable? It's also not recoverable because there is this dirty read. T2 has read the value written by T1, and the commit of T2 is not delayed until after the commit of T1. So the schedule is also not recoverable. if we allow the commit of T2 at this point and T1 fails, then T2 is already finished and can no longer be aborted. So this is not a good schedule. So at least what we want is that the commit of T2 is delayed until after the commit of T1, then the schedule is at least recoverable. If now T1 is aborted, also T2 can be aborted. Let's practice a bit with cascading rollbacks in the online system. Here we have a schedule with 6 transactions. The 4th transaction is aborted, and the question is, do other transactions need to be aborted as well? The 4th transaction writes the value D. Now let's check whether some transaction has read this value. Read of B, read of C, B, A. Here we have a read of D. Here we have a read of D. Now this read of D might refer to another write, so we have to check whether between this read and this write, whether there's another write of D in between. There's no other write of D in between, so this read really reads this value. So since the 4th transaction is aborted, the 3rd transaction needs to be aborted as well. Okay, there's no other read of D, so this has no further consequences, but here's a write of A. Let's have a look whether there's a read of A following this write. Yes, there's one read of A. This also is the 3rd transaction, so also because of this read, the 3rd transaction would need to be aborted. Okay, so the 4th transaction leads to the abortion of the 3rd transaction. Now let's check whether the abortion of the 3rd transaction has further consequences. The 3rd transaction writes C, so we are looking for a read of C after this write. Here's a read of C. Is this the only one? This is the only one. This is the only read of C. There's no write of C in between, so this read really reads this value of C. The 3rd transaction is aborted, so the 5th needs to be aborted as well. So since there's no other read of C, there's no further consequences, only the abortion of the 5th transaction. Now we need to check whether the abortion of the 5th transaction has consequences. We have here a write of E. Let's see whether there's a read of E. Yes, here's a read of E. Let's check whether between this read and this write there's a write of E in between. No, there's no other write of E in between, so this read really reads this value written here. Since the 5th transaction is aborted, also the 1st needs to be aborted. Okay, there's no other read of E. Here's a write of C. There's no read of C. Okay, so the 5th transaction only leads to the abortion of the 1st transaction. And the 1st transaction writes B, but there is no read of B following this, so the abortion of the 1st transaction has no consequences. Okay, so we have determined that the 1st, the 3rd, and the 5th transaction must be aborted. The 2nd and the 6th transaction do not need to be aborted. I have already solved the 2nd part of the task. Let's check whether our solution is correct. Yes, our solution is correct. Very nice. And again, feel free to continue practicing and simply ask for a new assignment.